For every water utility professional, understanding the proper methodology of sizing, selecting, and installing water meters for your commercial and industrial applications is extremely important to assure that the accurate revenues are collected. In part 11 of this series, we'll review the criteria that you need to take into consideration when planning a meter installation for your large meters. Let's dive into it. Well, let's dive into the specifics of installing a turbine or a compound first. On the back of the installation data sheet or the product data sheet for most meters, this diagram is going to be there, and most people just simply gloss over this diagram. I want to take some time to dissect this so you actually understand what they're showing and some of the things that you need to do and some of the things you need to avoid when installing a turbine or a compound. Well, let's start out with one of the basic premises. Always make sure in the vault, right, if you have a meter vault, make sure you have enough space around the meter to assure that you can easily read the meter, you can test it, and you can perform maintenance. Sometimes you get someone trying to save money on a meter vault, and it's so tight, it's so small that you can't get in and do what you need to do. That short-term cost of building the vault, if you try to shortcut that in the beginning, it's going to inhibit you for years in taking care of that meter and assuring yourself you're getting the right revenues. The second point that I'd like to talk about is the bypass. Where you can, especially in any type of new installation, make sure you install a bypass, either a permanent one or a temporary bypass. Why would I ask you to do that? The reason I ask you to do that is because there are going to be times where you're going to need to do maintenance to this meter. If the customer can't be shut down or the customer can't be without water for a period of time, you're going to want to be able to open that bypass and then be able to service this meter. We talked earlier about the strainer cleaning maintenance. If you don't have a bypass, you can't do those types of things, right? You can come in and you can close those valves off, but then the customer is going to be without water. So if you can put one of those on, I definitely recommend it. Sometimes people put the temporary on where they just put basically a fire hose there. The fire hose doesn't stay there, but you have the coupling there that allows you to put that on when you need to provide water and service the meter. The third thing that I want to talk about here is the amount of straight pipe. In any turbine or compound application, I always recommend putting a strainer. You need to have a strainer there because if you get a rock or a large piece of debris that comes down the pipe and it hits your turbine element and breaks off one of the fins, it's not going to record the correct velocity and infer that into the correct volume. You have to protect this element. It is a very delicate element. So I always say put in a strainer. When you put in a strainer, you need then 5 pipe diameters of straight pipe ahead of the meter. I'm going to break this down just to make sure we all understand this. What I mean by pipe diameters is this. If I have a 3-inch pipe, in this case this is a 3-inch compound meter here. If I have a 3-inch compound meter here and I have a 3-inch pipe, I'm going to want to have, in this case, 5 times that. I'm going to want to have 15 inches of straight pipe in front of the meter. That's when I have a strainer in place. Point number 4 here is that for some reason you can't put a strainer there. You need 10 pipe diameters of straight pipe ahead of the meter, right upstream of the meter. So if I've got a 3-inch pipe here, 3-inch meter, I'm going to have 30 inches of straight pipe ahead of that meter. Point number 5. If you're going to install a butterfly valve or a gate valve, the butterfly valve has to be a full open. The gate valve has to be full open, and it needs to be at least 5 pipe diameters upstream of the meter, right? It can't be right next to the meter. It's going to cause a disturbance in the velocity profile. Even if they're fully open, they're still going to cause a disturbance in the velocity profile and then skew your reading. Point number 6. Don't install pressure reducing valves or check valves upstream of the meter. Great disturbance of your velocity profile. If you must install a check valve, make sure it's located at least 3 pipe diameters downstream of the meter. If I have a 3-inch meter here, it needs to be at least 9 inches downstream of the meter in the bypass. All right. Pressure reducing devices must be a minimum of 5 diameters downstream of the meter. All right. Make sure you put them downstream, not upstream. If you have to have a backflow device, that backflow device needs to be 5 pipe diameters after the meter and bypass as well. If you have to put it before, and I don't recommend you doing that, but if you have to put it before, then it needs to be 15 pipe diameters upstream of the meter. Okay? Quite a ways upstream. So if I've got a 3-inch meter here, it needs to be 45 inches upstream of the meter. And the last point I want to talk about is this. If the meter doesn't have a test plug, which today most meters do, but if it doesn't and you need to install a service saddle or test tee for field accuracy testing, and you're all testing your meters at AWWA or state regulated testing frequencies, I hope you are, that needs to be 2 pipe diameters downstream of the meter. All right? Well, let's quickly run through the same discussion as it relates to an electronic meter. In this case, we're going to talk about an ultrasonic meter. The same types of things apply, but the numbers are different, right? Point number 1 is the same. We still want to make sure we have the space permitted to do testing or maintenance to this particular meter. Always install a bypass in this type of case as well. These meters do need to be tested. They don't have any moving parts. They can't really wear out according to AWWA and most state regulations. And of course, according to the new electronic meter standard, we still need to test these meters. I don't necessarily need to put a strainer in place for these meters because in most cases they are just simply open tube design. They're just, when you look through these meters, they're just an open pipe. The elements and or the electronics that are doing the reading are sort of recessed into the pipe, so you don't normally see them as you're looking through the pipe. So if a piece of debris went through there, it wouldn't affect that. In that case, I do need 5 pipe diameters of straight pipe before the meter. Now, I still need that velocity profile to look uniform as it comes across here as well. So I want to have at least 5 pipe diameters of straight pipe. Just like with the turbine or compound, if you've got to put a control valve here, put that downstream of the meter. You're going to avoid any type of cavitation here. If you have to install a check valve or pressure reducing valve, they need to be at least 5 pipe diameters upstream of the meter. Valves that are upstream of the meter need to be fully open valves, right? I don't want to have this skewing of my velocity profile. Here again, most of these meters today actually have a test plug on that meter for testing purposes. If you need to install that service saddle or test tee, it needs to be at least 2 pipe diameters downstream of the meter. If you have an unweighted check valve, it should be located at least 3 pipe diameters downstream of the meter. Pump discharge should be installed at least 5 pipe diameters upstream of a meter, right, in order to not skew that velocity profile. If you've got an externally weighted check valve here or a pressure reducing device, those need to be no closer than 5 pipe diameters of the meter. The last point that I want to talk about here is because of the wide operating range of ultrasonic meters, many times you might have an application where you can put a smaller meter than the pipe size that's already there. So if this is a current application, you might have a 6-inch pipe there. But you know what? A 4-inch ultrasonic meter might actually fit the application. In that case, you're going to want to put a contraction there, right, to downsize that. You might even have a strainer there. Well, when you do that, in order to eliminate that jetting effect as it comes down this pipe and goes down to the smaller size, you need to have at least 5 pipe diameters of straight pipe upstream of that meter. I know I went over those very quickly, but remember, these are on the application data sheets for every meter. The manufacturers tell you explicitly these points. The problem is most of us don't read them. So I want to make sure that you understand these points, and you don't have to remember them, but make sure you refer to those application data sheets when you're doing that installation. If you have any questions about today's topic, feel free to ask a question in the comment section below, and I'll personally provide you with an answer. Or if you'd rather send a private message or have any questions related to metering or meter reading systems that I can help you with, be sure to connect with me on LinkedIn. Our question of the day: what other aspects of meter sizing, selection, and installation do you want to know more about? Please provide your question in the comment section below. If you found value in this content, be sure to click the like button. And if you have a colleague that would benefit from listening to this episode on sizing and selection, be sure to share it with them by clicking the share button. Stay tuned for part 12 of this series, where we will dissect the step-by-step process that I put together to easily guide you through the sizing and selection process. We'd like to thank you for watching this video, and we'll catch you next time on the Smart Water Show.